Good day, everyone. Welcome to this exciting presentation on Reflexion language agents with verbal reinforcement learning. Today, we delve into a groundbreaking approach that addresses the challenges faced by autonomous decision-making agents built on large language models. Traditional reinforcement learning methods are not only computationally intensive, but also lack the ability to learn efficiently from past mistakes. Reflexion introduces a novel verbal reinforcement learning method that transforms feedback into actionable insights, allowing agents to improve rapidly through self-reflection. This method promises not only enhanced efficiency, but also greater interpretability in learning complex tasks. Join us as we explore the significant implications and detailed insights of this innovative research. Autonomous agents powered by large language models have shown promise in various decision-making tasks. However, these agents often struggle to learn from their mistakes and improve over time due to the limitations of existing reinforcement learning methods. These traditional methods not only require substantial computational resources, but also lack clarity and interpretability, making it challenging to diagnose and enhance agent performance. In response to these challenges, prior works such as React, Saycan, and others have leveraged large language models to generate text and actions. Despite their innovative approaches, these methods are still constrained by traditional optimization techniques and limited teaching methods, which do not adequately support the agents in learning from their errors in an efficient and interpretable manner. This highlights the need for a new approach that addresses these shortcomings, paving the way for more effective and autonomous learning agents. Reflexion introduces a novel approach to reinforcement learning by utilizing verbal feedback, a method that mirrors the iterative learning process seen in humans. This technique transforms environmental feedback into textual summaries, which are then used to guide the learning of large language models without the need for fine-tuning. This not only streamlines the learning process, but also significantly reduces computational demands. Our key contributions through Reflexion are manifold. Firstly, it accelerates the learning process, enabling agents to rapidly improve their performance across a variety of tasks. Secondly, it enhances the interpretability of the agent's decision-making processes and aligns their goals more closely with intended outcomes. This is achieved through the mechanism of self-reflection, where agents assess their actions and adapt based on verbalized feedback, fostering a deeper understanding and more strategic future actions. As we delve into the realm of autonomous decision-making agents, it's crucial to understand the significant role that large language models, LLMs, play in contemporary AI tasks. These models are not just limited to generating text, but are pivotal in decision-making, programming, and reasoning tasks. The figure displayed here encapsulates the reflexion method and its reinforcement algorithm, illustrating the core components and the process flow. This innovative approach leverages verbal reinforcement, allowing agents to learn from prior mistakes and iteratively refine their strategies for improved performance in complex tasks. This method represents a shift towards more interpretable and adaptive AI systems, setting a new standard in the field of autonomous agents. As we delve into the motivation for our new approach, it's crucial to recognize the limitations of current reinforcement learning methods. These methods are not only computationally intensive, but also lack the interpretability needed for broader application and trust. This highlights the need for more efficient and interpretable methods that can enhance learning from mistakes, allowing agents to improve autonomously over time. Turning to the problem setting, our focus is on agents based on large language models. These agents typically rely on massive models and slow optimization methods like gradient descent. Furthermore, existing models do not have effective mechanisms for learning from past failures, which significantly limits their ability to improve autonomously. The importance of addressing these issues cannot be overstated. Improving autonomous decision-making is crucial for the real-world interaction of AI systems. Moreover, making AI agents more interpretable and aligned with human values is essential for their safe and ethical integration into our daily lives. This sets the stage for our proposed solution, which we believe addresses these critical gaps. In exploring the landscape of autonomous decision-making agents, we've identified significant limitations in previous methodologies. Traditional approaches often rely heavily on in-context examples, which restrict the agent's ability to learn from past mistakes. Additionally, the use of scalar or vector rewards in conventional reinforcement learning complicates the process of learning from feedback, as these rewards do not provide clear directional guidance for improvement. To address these challenges, we introduce Reflexion, a novel approach that leverages verbal reinforcement to enhance learning. Reflexion transforms environmental feedback into textual summaries, which are then incorporated as episodic memory. This process not only allows the agent to reflect on its actions, but also facilitates iterative learning from one episode to the next. Key innovations of Reflexion include its avoidance of fine-tuning large language models, which significantly enhances computational efficiency. Moreover, by utilizing natural language summaries as a form of episodic memory, Reflexion aids in long-term learning and improves task performance across various domains. This method represents a substantial shift towards more interpretable and effective learning mechanisms in the field of autonomous agents. Let's delve into the core of our proposed method, Reflexion, which introduces a novel approach to reinforcement learning through verbal feedback. Unlike traditional methods that rely on scalar or binary rewards, Reflexion transforms these inputs into detailed textual summaries. These summaries are not just feedback, they serve as enriched context for the agent in future learning episodes. This mechanism allows the agent to reflect on its actions and outcomes, much like a human would after receiving constructive feedback. By integrating these reflections into its memory, the agent iteratively enhances its decision-making and problem-solving capabilities, paving the way for more sophisticated and nuanced learning trajectories. This approach not only aids in the agent's learning process, but also enhances the interpretability of its actions, making it easier for us to understand and improve the underlying models. Let's delve into the technical specifics of the Reflexion method, which is designed to enhance the learning capabilities of large language models without the need for extensive retraining. Initially, Reflexion utilizes the existing parameters of a large language model, leveraging its pre-trained capabilities to interpret and act within various scenarios. The method incorporates three distinct feedback mechanisms. First, it uses binary feedback from the environment, which indicates success or failure. Second, it employs predefined heuristics to identify common failure modes. Lastly, it integrates self-evaluation techniques, where the model assesses its own performance. This feedback is then transformed into natural language summaries. These summaries are not just textual, they are crafted to contain actionable insights, helping the model to understand and rectify its mistakes. This process mimics human learning, where feedback helps in refining skills and knowledge. Finally, these reflective summaries are stored in the model's long-term episodic memory. This storage not only preserves the context of past experiences, but also enriches the model's ability to handle similar future tasks more adeptly. By iterating through this process, Reflexion enables continuous improvement in decision-making, reasoning, and programming tasks. Let's delve into the algorithmic framework of Reflexion, our proposed learning cycle that enhances agent performance through verbal reinforcement. The cycle begins when the agent performs a task and receives initial feedback, which can be either binary or scalar. This feedback is then transformed into a detailed textual summary, capturing the essence of the agent's performance and pinpointing areas for improvement. This summary isn't just a passive record, it's actively used as additional context in the next learning episode, effectively informing the agent's future actions. By reiterating this cycle, the agent progressively refines its approach, leveraging insights from previous summaries to enhance its decision-making and task execution. This iterative learning mechanism mirrors human learning processes, where reflection and incremental improvement play crucial roles. Let's delve into the design and implementation of our experiments, which are crucial for understanding how Reflexion enhances agent performance across various tasks. We conducted tests in three distinct environments: Outworld for decision-making, Hotpot QA for reasoning, and HumanEval for programming. Each environment presents unique challenges and tasks, tailored to assess specific capabilities of our agents. For instance, in AlfWorld, agents navigate complex decision-making scenarios, while in HotPot QA, they tackle intricate reasoning questions. In HumanEval, the focus shifts to programming, where agents must write and debug code effectively. To quantify improvements, we compared the performance of Reflexion agents against strong baselines, measuring accuracy enhancements and other relevant metrics. This rigorous approach allows us to validate the effectiveness of Reflexion in diverse settings. Moving on to the innovations brought about by Reflexion, it's important to highlight how this approach addresses some of the inherent limitations found in traditional reinforcement learning methods. Reflexion is not only computationally efficient, as it avoids the need for extensive fine-tuning, but it also enhances interpretability, a critical aspect when agents interact in complex environments. Moreover, the use of verbal feedback, mimicking human cognitive processes, marks a significant departure from conventional methods. This feedback mechanism not only accelerates learning, but also aligns agent actions more closely with human reasoning, ensuring that agents can learn effectively from their experiences and improve over time. Let's delve into the technical results and their implications. Our findings demonstrate that Reflexion significantly enhances the learning capabilities of large language models across a variety of complex tasks. By integrating verbal feedback and self-reflection, agents not only learn, but adapt more efficiently compared to traditional reinforcement learning methods. This suggests a promising direction for developing more robust and adaptable AI systems. Turning to our ablation study results, we observed a notable decrease in performance when internal test generation and execution steps were removed. This highlights the critical role of complete self-reflection cycles in the learning process. Additionally, omitting natural language explanations after failed tests resulted in poorer performance, further underscoring the importance of verbal feedback. These results collectively emphasize the necessity of integrating comprehensive feedback mechanisms to foster effective learning in AI agents. Moving on to the implications of our ablation studies, we've observed a notable decrease in performance when certain steps of the Reflexion method are omitted. This underscores the critical role that each component plays in the overall effectiveness of the system. It's clear from our findings that integrating comprehensive self-reflection and feedback mechanisms is essential for handling complex tasks effectively. Delving into the technical details, Reflexion leverages existing large language model parameters and memory encoding without the need for fine-tuning. This contributes significantly to its efficiency. Moreover, the method's ability to convert environmental feedback into actionable natural language summaries is key to its success. This transformation of feedback into a format that is both understandable and useful for the model enhances its ability to learn and adapt from past experiences, driving improvements in task performance. As we conclude, let's reflect on the innovative approach of Reflexion, a novel verbal reinforcement learning method that significantly enhances the capabilities of autonomous agents. By integrating verbal feedback directly into the learning process, Reflexion allows agents to guide their actions and improve through self-reflection on past mistakes. This method not only boosts the agent's performance in complex decision-making, programming, and reasoning tasks, but also does so across various domains, as illustrated in the figure shown. Reflexion stands out by transforming traditional reinforcement learning, making it more interpretable and aligned with how humans naturally learn and adapt. This approach leverages the power of language to provide clear, actionable feedback, enabling agents to refine their strategies and learn efficiently from fewer interactions. This capability is crucial for developing more autonomous, robust, and intelligent systems that can operate effectively in dynamic and unpredictable environments. Let's delve into the mechanism of Reflexion, a novel approach that transforms feedback into actionable textual summaries. This feedback is not merely stored, but integrated as episodic memory, enhancing the learning process. Reflexion employs a variety of feedback methods, including binary feedback, predefined heuristics, and self-evaluation, which collectively contribute to a robust learning environment. Moving on to the performance gains, Reflection significantly outperforms traditional reinforcement learning methods. It has proven effective across a range of tasks, including decision-making, reasoning, and programming. Our tests in diverse environments, such as AlfWorld, Hotpot QA, and HumanEval, showcase its versatility and effectiveness. To summarize the key takeaways, Reflection facilitates rapid and effective learning through its unique use of textual feedback. This approach is not only lightweight, avoiding the need for fine-tuning large language models, but also conserves computational resources, making it an efficient choice in advancing autonomous agents. This innovative method marks a significant step forward in the field of AI, combining the power of language with the precision of machine learning.